Hello, welcome to my mathematics session. Today's class is about the complex form of a Fourier series. I have taken a problem f of x is equal to e to the power of ax defined in the interval minus pi less than x less than pi, and we have to develop this as a complex Fourier series in the complex form. Now see, we know that, I'll write here, we know that the complex form of the Fourier series of f of x in, say, whatever it is given, we will take it to be in minus pi to plus pi, is given by f of x is equal to, it is n is equal to minus infinity to plus infinity Cn, then e to the power of I n x. So this is the complex form of the Fourier series of any function f of x given in the interval minus, even it can be 0 to pi or minus pi to plus pi. You see that this will be the form of this, where this Cn is the Fourier coefficient and it is given by 1 by 2 pi minus pi to plus pi f of x e to the power of minus inx into dx. So here, if it is the interval 0 to 2 pi, it will from 0 to 2 pi. If you have it as minus L to plus L, means it is a different form. Then I will teach you how it should come. But here, if you have it as minus pi to plus pi, then it is 1 by 2 pi minus pi to plus pi f of x e to the power of inx dx. And if it is 0 to pi, means 1 by 2 pi, 0 to 2 pi, you will have it. Now, I have, what is my job? I have to find, this is the Fourier coefficient, this is the Fourier series, and this is the Fourier coefficient, and this Fourier coefficient Cn has to be determined, and you have to substitute in this place so that you will get the Fourier series in the complex form. So this is how the method of doing it. So first write this. What is the complex form of a Fourier series? You give it. Then you define what is, according as what is the interval, you state the Fourier coefficient. Then find its value, substitute here, you will get the answer. That's all. This is what you should do. Now, I'll write here. Now, Cn, now you tell me what is my Cn. It is 1 by 2 pi, it is minus pi to plus pi. What is your f of x here? Your f of x is, see, f of x, I'll write here. See, f of x, I'll write here. What is your f of x now? Here we can write, see, your f of x is e to the power of ax into e to the power of minus inx dx. So this is equal to, I will write this as 1 by 2 pi, it is minus pi to plus pi, e to the power of x into a minus in into dx. So this is what you will have here, that is, this is e to the power of ax, that is e to the power of minus inx, and for this x is common, you pull that out and you will get this. Now the integration of this is very, very simple. So what is it equal to? It is 1 by 2 pi e to the power of x into a minus in divided by a minus in, and this must be with the from a raised to limits minus pi to plus pi. That's all. Now, so this will be equal to, see what is that? It is 1 by 2 pi, then open a bracket, substitute now I e to the power of pi into a minus in minus e to the power of minus pi into a minus n divided by, it is a minus in. So what is that I have done here? I have substituted the first limit plus pi, upper limit pi, and then the lower limit. Then you see that this can be written as 1 by 2 pi a minus in, multiply it by its conjugate a plus in, and divide also by its conjugate. This is what you will have, and then inside this you write it as e to the power of a pi into e to the power of, you will have it as, this is I minus I pi n. See here, you take this pi inside, then it is minus e to the power of minus a pi, then you take this minus sign inside, it will be e to the power of I n pi. I have not done anything except taking this pi inside, pi a minus I pi n, it is minus pi a plus I pi n. So this will be equal to, I will write it here. So here you see that this is a plus in divided by 2 pi into, this is a minus in into a plus in is what? A squared plus n squared. Inside the bracket you have got e to the power of a pi, pi a or a pi, whatever it is. Then it is, I will write this as cos n pi plus I sin n pi. This is using De Moivre's theorem. It is minus e to the power of ix is what? Cos x plus sin x. If you have it as e to the power of minus ix means what? Cos x minus I sin x. So you see that using De Moivre's theorem, I can write this as a cos n pi minus I sin n pi. Then minus e to the power of minus a pi or pi a, whatever it is, and this is cos n pi, then it is plus I sin n pi. So this is what you have. Now coming to this, see, this is sin n pi, this is sin n pi, sin n pi, sin n pi, this is sin n pi. Sin n pi. So you see that sin n pi, I will write here cos n pi. Cos n pi is equal to minus 1 to the power of n. Sin n pi is equal to 0 for all n. Now you see that cos n pi is equal to, if it is for odd multiple it will be minus 1. For even multiple it is plus 1. So it is cos n pi is equal to minus 1 to the power of n, whereas sin n pi is equal to 0 for all values of n. So this is what we get. So you just put it here so that this will become 0 and this will also become 0. So what are you left with now? It is a plus in divided by 2 pi a squared plus n squared into, I will write this as e to the power of a pi minus e to the power of minus a pi into, it is cos n pi. So you see that this becomes 0 and this is also 0. This one 0. I mean this one 0. This is sin n pi is 0, sin n pi is 0. Here you get what? Cos n pi. Here also cos n pi. You see that you take that outside, a to the power of a pi minus a to the power. So this is, so what is that you will get here? So this is a plus in divided by 2 pi a squared plus n squared into, I will write this as, it is e to the power of a pi minus e to the power of minus a pi into, it is minus 1 to the power of n. So I told you minus 1 to the power of n. So this is what we get on substituting and making this as 0, because sin n pi is equal to 0. So what is that you will get here now? I'll write here. So this Cn will be equal to, so it is a plus in divided by 2 pi into a squared plus n squared into, I will write this as e to the power of a pi minus e to the power of minus a pi divided by 2 and also multiply it by 2. Or you can bring this 2 also here, no problem. So you see that into it is minus 1 to the power of n. Either you bring this 2 here or multiply it divided by 2, both mean the same. So what is that you will get here now? So this is equal to, I will write here, it is a plus in divided by 2 pi into a squared plus n squared, and here you can write this as sin h a pi into 2. I will write this 2 here. It is minus 1 to the power of n, because since we know that e to the power of minus e to the power of x minus e to the power of minus x divided by this is equal to sin hx. If it is plus, it is cos hx. If it is hyperbolic function, if it is plus here, you will get cos hx. If it is minus here, you will get sin hx. So I have used, so in the place of x, you have got a pi, so multiply it and divide it by 2, so that this will take the form of sin h. In the place of x, you have got a pi, so this is what I will get. Now you see that this 2 and this 2 will get cancelled, giving you what? What is the answer that you will get now? So this will be equal to, a plus in divided by pi into a squared plus n squared into, within brackets, sin h pi a into minus 1 to the power of n. So this is the value of Cn. So this is the value of Cn. Having got the value of Cn, you see that you can just write the Fourier series. Now the complex Fourier series is, therefore the complex form of the Fourier series of of f of x is equal to e to the power of ex is, see, f of x, see, what is what is that we have written here? It is e to the power of ax is equal to, it is minus infinity to plus infinity cn into e to the power of inx. Okay, now therefore that is f of x is equal to e to the power of ax is equal to, now you see that it is n is equal to minus infinity to plus infinity. You have in the place of cn, what is that you will write here? A plus in divided by pi into a squared plus n squared into minus 1 to the power of n into sine h pi a. So you take this outside, so whatever, whichever is not involving n, you can pull them out, so you will get this as, it is sine h pi a divided by this pi, and it is minus infinity to plus infinity a plus in divided by a squared plus n squared into, I will write this as minus 1 to the power of n first, then it will be correct. So it is minus 1 to the power of n into a plus in divided by a squared plus n squared into, here you see that this series is e to the power of inx. So this is equal to what? Sin he into either. So this is into e to the power of inx. So this is your series. So what is that? So I will write here. So the Fourier series is given by, the Fourier series is Fs is equal to, write this, sine h pi a divided by pi, it is minus infinity to plus infinity minus 1 to the power of n a plus in divided by a squared plus n squared into e to the power of inx. So this is my answer. So this is the complex form. See, you can see that here everything comes here, so this is in the complex form. I'll just give you a general idea of how this complex form comes. That is, I'll just give you, see, so the problem is over. The problem is the complex, getting the complex form of the Fourier series is over. I'll just give you some idea on this. So I'll write something here. We know that f of x is equal to, it is a naught by 2 plus n is equal to 1 to infinity of an cos nx, and n is equal to 1 to infinity of bn sin nx. F of x given, and x lies in minus pi to plus pi. So if this is given, so you see that this can be written like this. Now we know that, see, you can write this an, you can write this as, see, this one, I will take this, see, sigma of 1 to infinity of an cos nx can be written as, it can be written as 1 to infinity of an, it is e to the power of inx plus e to the power of minus inx. It is, you will get, divided by 2. So this is what you will get. So in this place, see, I will this e to the power of nx is this, and your this one I can write this as bn into sine nx will be equal to, it is sigma of bn 1 to infinity, it is e to the power of inx minus e to the power of inx divided by 2a. So these are the values. See, sin nx is this one and your cos nx value is this. Now I will substitute this in these places. I will substitute in these places. So what I will get here is, so what is that you will get here? F of x is equal to a naught by 2 plus, it is sigma of 1 to infinity. Now you see that when you substitute here, they see, I will write it in such a way that an, say an, I will write it as an by 2 plus bn by 2i into e to the power of inx plus 1 to infinity of, it is an by 2 minus bn by 2i into, yes, bn by 2i into e to the power of minus inx. So what I will do is, I will substitute the values here and collect the coefficients of e to the power of inx, and here I collect the coefficients of this one. So here what I will do here is that it is a naught by 2 plus, it is 1 to infinity of an, it is minus ibn divided by, it is 2. You know how I get this? You multiply the numerator and denominator by I. So it is ibn is here. Here I squared will be minus. So it is minus ibn divided by 2 into inx. E to the power of inx. Plus, here the same thing I will do here. It is 1 to infinity. Here again, no, an plus ibn divided by 2i. Here also, if you multiply, it is 2 only. So it is 2. So you multiply and divide it by 2 into e to the power of minus inx. So I have not done anything except what is that? I am taking this to be what? An by 2. I multiply this by I and multiply this also by I. So it will be I square, it will be my plus. So I am getting this. Now I will do some, see, the small manipulations we do and try to get that form, complex form of the Fourier series. So what is that you get here? So your f of x will be equal to a naught by, so this I will write it as 1 to infinity of, it is cn into e to the power of inx, e to the power of inx, plus it is 1 to infinity of, it is c minus n e to the power of minus inx. So I will write this as what? This I will call it as. So what is that I have done here? I have simply named the coefficients here, where here and everything I will rub it off, where Cn is equal to, you can call this is minus, so you call this as minus conventionally, this is n. So this one will be what? It is C minus n will be your an minus ibn. So you can take this this one, take this half outside, here also take this half outside. It is C minus n is equal to so much, and Cn is equal to an plus ibn. So this is what I get. Now you see that I will put it here. So this one I have got here. So this one I will write it as C naught. This one I will write it as C naught. C naught by 2 plus half into C minus n e to the power of I n x plus half into, it is half into sigma of n is equal to, here see that 1 to infinity, here n is equal to 1 to infinity, it is Cn into e to the power of minus Inx. So this is what. Now if you combine all these things, if you combine these, what is that you will get here now? So this is nothing but, it is, I think what you have to do here is, you have to take this, see, take this, so this is, in the place of this, an minus ibn divided by 2, I have written C minus n. And this one, you know, C naught, I will write it here. This one, C naught plus this, I'll write it like this. So this is what I get. Now these things can be combined and put in a single form as, it is nothing but minus infinity to plus infinity e to the power of Inx. So this is what you get. So you see that if it is minus infinity to 0, if it is minus infinity to 0, you get this one, and if it is 1 to infinity, you get this. For 0, you get this. So these three, all these three things can be put in the form of what? It is minus infinity to plus infinity Cn Inx. This is nothing but your complex form of, this is your what? Complex form of Fourier series of f of x, where this Cn will be equal to 1 by 2 pi minus pi to plus pi. It is f of x into e to the power of Inx dx. So this is what you will get. So you see that this is the idea behind the Fourier series in the complex form. So if you are asked to get the complex form of a Fourier series for a function, then you have to write this formula. What is this formula? F of x is equal to minus infinity to plus infinity Cn e to the power of inx. And here I will give that if it is going to be your x belonging to minus L to plus L, then your f of x will be equal to, it is nothing but what? It is minus infinity to plus infinity. It is Cn e to the power of in pi x by L, and that your Cn will be equal to, it is 1 by 2L, it is minus L to plus L, it is f of x into e to the power of minus in pi x by L. So I will repeat this. See, I have written at the end here. See here, this is for the x defined in minus pi to plus pi. By chance you are given an interval, x is lying in the general interval minus L to plus L, means the same formula you can use. Here what is that? See f of x is given by what? Your f of x is equal to minus infinity to plus infinity Cn in the e to the power of, it is e to the I to the power of pi n x by L. Say I have written here pi n x divided by L. See, this is how you must write. E to the power of, see, e to the power of I n pi x by L. So this is how you must write. So this is what I have written here. So I e to the power of I n pi x by L, and your Cn value will be equal to 1 by 2L integral of minus L to plus L f of x into e to the power of I n pi x by L into dx. So this is how. So these are the things that you must remember. So when a function is given, write this. If you want the Fourier series in complex form, write this formula, then Cn write like this, do all manipulations and get the answer. So this is about the complex form of a Fourier series. I will teach you more on harmonic analysis and solving a wave equation and a heat equation in the coming days. Thank you.